last day we have already seen and we have started to solve the transportation problem. And here is an example of the transportation problem where it is having 3 origins and 4 destinations. And we have already seen previously there are 2 steps. The first step was to check the problem is balanced or not. The problem will be balanced if total availability is total demand. Availability is for the origins, that is 100, 80 and 90 are the availabilities, and the demands for the destinations are 60, 70, 75 and 65. And if the total availability is equals to the total demand, in this case it is 270, and then the problem is balanced. So if the problem is balanced, we go to the second step. In the second step, we find the initial basic feasible solution by 3 different methods are there. That is, one of them is matrix minimum method, the other one is log to corner method, and the third method that we have discussed is Vogel's approximation method or VAM. And we have already checked and we have already found out the allocations using those 3 different methods. Then is the next step. Okay. Then the third step of the solution of transportation problem is the optimality test. The third step is the next step, that will be termed as optimality test. Optimality test. So third step is the most important step in the transportation problem, because our objective is to find out the minimization of transportation cost. And the solutions that we have obtained, the initial solutions that we have obtained by 3 different methods may be optimum, may not be optimum. So we have to check the solutions that we have obtained, whether they are giving minimum transportation cost or not. For that we need to do something that is called optimality test. Now, to go to the optimality test, another thing is to be checked. In this case, in the previously we have discussed, for this particular case, there are 7 constraints, 3 for the origins and 4 for the destination. Actually there are 6 constraints and the number of variables are 12. x11, x12, x13, x14, x21, x22, x23, x24, x31, x31, x32, x33 and x34. So there are 12 variables and 7 constants. And out of the 7 constants, there are 6 independent constants. So that means if we are talking about the constants, the equations, there are 6 basic variables in this case. So before going into the optimality test, we must check the number of basic solutions. The number of basic solutions for a transportation problem having m rows and n columns. That is the cost matrix with m cross n cost matrix. For that transportation problem, the number of basic solutions is m plus n minus 1. M plus n minus 1 is the number of basic solutions, where m is the number of rows, n is the number of columns, minus 1. So in this case there are 3 rows, 4 columns. So m plus n minus 1 is 6. And we have to check the number of basic solutions that we have got. So in this case we have got 1, 2, 3, 4, 5 and 6. So if there are 6 basic solutions we have got, then we can proceed to the optimality test. Otherwise, we have to do something different. To do the optimality test, as I have said, we have to check the number of solutions. So number of basic solutions will be m plus n minus 1. In this case, that is 6. So there will be 6 basic variables and other 6 will be non-basic variables. So other 6 variables will be having the value as 0. So in this case, we have got already obtained 6 basic variables. So we can proceed to find out to continue with the optimality test. The method that we will be doing for the optimality test, The name of the method is called MODI method, M-O-D-I. MODI method. So MODI method is modified distribution method. There are several methods available to check for the. There are several methods available to check the optimality test. Another method that we have is stepping stone method, but we will discuss only the modified distribution or MODI method for doing the optimality test. In MODI method, what we have to do is we have to calculate certain values. Those are named as UI and VJ. And actually they are shadow prices or no. Now we have to calculate UI and VJ for allocated cells. It's very important to keep that in mind that for allocated cells, the following formula must satisfy. Cij is equals to UI plus VJ. So we have to calculate UI and VJ in such a way for the allocated cells that this condition must satisfy. Cij is equals to UI plus VJ. UI and VJ are certain quantities. UI and VJs are quantities that represent actually shadow price, which can be obtained using this formula. Now this is true for allocated cells. So what are the allocated cells that we have? So this is one of my allocated cells, this is another allocated cell, this is another allocated cell. So these are the allocated cells where I have put the ticks. So for those cells, this condition has to be satisfied. So there are 6 allocated cells and we have to calculate 3 UIs, that is U1, U2, U3 and V1, V2, V3, V4. So if I write that as this is U1, U2, U3 and we have to calculate V1, V2, V3 and V4. So there are total 7 values are to be calculated and we have 6 allocated cells. So that means if we put the values in place, we will be getting 6 relationships, 6 conditions to find out 7 values. So what we will do, we will just choose any one of the UI and VJ, any one, because 7 conditions are there. 7 values are to be found out, but 6 conditions are there. So we have to take any value, one variable as any value, and by putting that we will be finding the other values. So choose any value as 0. In fact, instead of 0 you can choose any possible values, but for simplicity of calculation we can use the value as 0. So initially I'll do this for the 3-4 times, and initially I'll take, say, U3 is equals to 0. As I've said, you can take any, not U3, V3 as 0. You can take any value as 0 and calculate the other values. So if you take V3 as 0, then what are the allocated cells? So all 3 of them are allocated cells in this column. So according to the formula, Cij, that is C13, I'll just write 1. In this case, this is C13 is equals to U1 plus V3. So C13 is U1 plus V3 according to the formula that Cij equals to Ui plus Vj. So C13 is equals to U1 plus V3 and the value of C13 is 20. U1 is to find out and the value of V3 is 0 that we have already put. So that gives you the value of U1 as 20. So simply we will just check, mind that this is Xij, this is your Cij that I have already explained. These are the costs we are talking about, these are the allocations, these are the variables, Xij and this is Cij. So if you have taken this as 0, correspondingly this plus this will give you this. So if this is 0, this is 20, this must be 20. Similarly, if this is 0, this is 25, this must be 25. Same formula, and this is 0, this is 19, this must be 19. Now, when I have already got this, then I will check what are the other cells that are allocated cells. So I have already used up this, I didn't use this. So according to this formula, this plus V4 is equals to C14. U1 plus V4 equals to C14. So this gives you V4 as minus 2. Because 20 minus 2 gives you 18. Similarly, for this row, we will check where is the allocated cell. So this is one allocated cell I have already used. So another allocated cell is this. So if this is 25, this is 16, this must be minus 9. Because V1 plus U2 gives you C12. C12 is V1 plus U2. So this value is 16, this value is 25, this gives you minus 9. And similarly, this one 19, this one 18, because I have already used this. So 19 and 18, this gives you minus 1. So by using that particular formula, Cij for allocated cells, Cij is equals to Ui plus Vj. So Cij equals to Ui plus Vj for allocated cell. From this formula, we can calculate all the values of Ui and Vj. We can calculate all the values of Ci, Ui and Vj. So as I have said, I will be calculating again to make you the formula more understanding. So again we will calculate Ui and Vj using the same formula. Mind that Cij is equals to Ui plus Vj only for the allocated cells, the cells which are already been allocated. So last time I have taken this as 0, now I will choose U1 as 0. So how to find out U2, U3, then V1, V2, V3 and V4. So this is a repetition that I am doing. So when I have taken this as 0, I will check what are the allocated cells in this row, because this is associated with row. So from this and this, I will get this value. So if this is 0, this is 18, this must be 18. Because this plus this is equals to this according to the formula Ui plus Vj. So U1 plus V4 is equals to C14. So U1 was 0, C14 was 18, that means that gives you V14 as 18. And similarly, another one, this is 0, this is 20, this gives you 20. So if this is 20 and I have already used up this, so using this 2, I'll get this value. So U2 plus V3 gives you C23. So C23 is 25, U2 is 20, that means this V3 is 20, that gives you U2 is 5. So this plus this equals to this. And similarly, if this is 20, this is 19, because this is the allocated cells, this gives you U3 is equals to minus 1, because add this and this, you get this. So when you get this is minus 1, you check where is the allocated cell here. We have already used up this. Then this is next allocated cell is this. So this is minus 1, this is 18, gives you this value as 19, because this plus this is equals to this. Same formula we are doing, and using this U2 and C21 gives you V1. So if this is 16, this is 5, this gives you V1 as 11, because 11 plus 5 is equals to 16. So for this method, you just try to repeat, but only one calculation is sufficient. You can take anything as any one as 0, as I have said. So you can choose. For this, practicing is important, because this is the most important. The calculation is simple, but if you try to write all the equations, it becomes a quite lengthy one. But practicing this will help. So you can choose any one as 0, and similarly you can calculate. After you have found out Ui and Vj for the allocated cells, the next step in the optimality test is to calculate certain other values for non-allocated cells. So for non-allocated cells, for non-allocated cells, see, you have to calculate Wij, which is equals to Cij minus Ui plus Vj. So you have to calculate, mind that this is for non-allocated cells, you have to calculate Wij. Wij is equals to Cij minus Ui plus Vj. And the optimality condition is if all Wij are greater than equals to 0. If all Wij are greater than equals to 0, then the solution is optimum. So we have to calculate Wij for all other cells, and please check how I'll write. Alright. So for this is the non-allocated cells, I have to calculate the Wij value. So this is 20 minus 0 plus 11. That gives you 9. So I'm using this formula. Cij is 20, Ui and Vj is there. So in this case 24 minus 90 also gives you 5. That's a positive value. See, this is an allocated cell, so I will not calculate the Wij in this case, but this is a non-allocated cell, I will calculate. So this is 19 minus 5 plus 90, so this gives you minus 5. So that's a negative value in this case. This is 5 and 18. So 21 minus 5 plus 18, that is 21 minus 23 gives you minus 2. And in this case, this is 20 minus 11 minus 1. So 20 minus 10, that gives you 10. And in this case is 23 minus 18 minus 1, that is 23 minus 17 is plus 6. Mind that the positive values are not important, but the negative values are important. So as you can see, we have got two negative values, and I have said already that if all Wij are greater than equals to 0, the solution is optimum. That means in this case the solution is not optimum. So as we have said that here we have found out two Wij values that are negative. That means the solution that we have obtained is not optimum. So I need to improve the solution. I have to do something so that the solution can improve. Now listen very carefully what I will be doing. Now to improve the solution, what you have to do is to draw a very small prototype of the now to test. So we have to improve the solution. Now to improve the solution, we have to draw a prototype of the cost matrix and plot. I'll just indicate the allocated cells over there. So by a dot. So these two are my allocated cells. Then there, and there. So these 6 were the allocated cells. And then what you have to do, now listen carefully, that's what I will say. To improve the solution, we have to form a loop starting from the most negative Wij value. We have to form a loop through the existing allocated cells in such a way that it will come back to the same cell. Means loop means something a figure which will start from a particular cell and come back to that same cell with perpendicular lines, and the edges will be perpendicular to each other, and it can take a turn where there exists an allocated cell. So starting with the cell having most negative Wij value. So here there are two negative values, -5 and -2. So most negative Wij value is -5. That means we have to start from this cell and form a loop. So the loop is like this. Now, it is not necessary that the loop has to travel through all the existing allocated cells. It's the minimum loop that you have to form, and the loop is from where it is starting. It will go. It could have gone this way, but then there is no way it can turn. So you have to take the loop, make the loop in such a way where it can take turn, and the turn can be taken where at the end there must be an allocated cell. And what we will do, we will write the allocated values. So there it was 20, here it was 20, and here it was 70. So now this cell, as you can see, the value cost matrix or cost value was 19 over here and 25 over there. So obviously, instead of 25, if we had put in 19, some cost could have been saved. So that's what we will be trying to do. So from the two adjacent hands of the loop, these two are the adjacent hands, the minimum allocation. So what are the allocations to the adjacent hand? 20 and 70. These two are the allocations in the adjacent hand. So the minimum allocation will come to that cell. That means here it was 0, now it will become plus 20. So if it is plus 20, so total adjustment needed to be done. So it has to be minus 20. So if it is minus 20, then row wise, column wise, the total adjustment needed to be done. So it will be plus 20. And if it is plus 20, it has to be minus 20. So here, alternatively, plus and minus has to be done. So here, that 20 and 70 will compare 20 and 70. The minimum value will come here. So 0 plus 20. So if 20 increases in this column, so 20 has to be decreased. So that's why I'm doing 70 minus 20. So here if it is decreased, then or next one it will be increased. So 20 plus 20, and that's how the total balancing remains unchanged. So the new improved solution becomes, let's write it again, write the table in a fair way. So after the new allocation, the new allotment becomes, the values are 20, 24, 2018, 2016, 19. These are the costs, 25 and 21. Then 20, 18, 19, 23. And the new allocation becomes, this remains unchanged. X13 and X14 remains unchanged. X21 also remains unchanged. Now X23 has become 0 because 20 minus 20 has become 0. So if it is 0, it has become non-basic. So I'll not write that non-basic value. I'll write now that at 19 now it has become 20. So if it is 20, then correspondingly at 3-2 it becomes 50 because the total requirement of the column 2 was 70 units. So if it is 20, then it has to be 50, otherwise the adjustments would not be done. And if this is 50, then it will become 40. So 1, 2, 3, 4, 5, 6. So this is the new allocations that we have. And again, we have to check whether the current solution, and if we check the cost, the cost could be, and the cost in that case, if you check, it can be 35 into 20 plus 65 into 18 plus 16 into 16 plus 20 into 19 plus 50 into 18 plus 40 into 19. So this gives you 35 into 20 is 700 plus 65 into 18 is plus 960 plus 380 plus 900 plus 760 and 65 into 18 is total value becomes 4870. 65 into 18 is how much is 65? 65 into 10 is 650. 8 into 65 short 48. So the value becomes 5 into 18 is 90. Short plus 90 is 1170. So 1170. So if you add, you will get 4870. You get 4870. So the cost, you can check that the cost has already increased. Previously, when you have used the matrix minimum method, the cost was something like 5,300 or I can't remember. But now you can see that the cost has already reduced. The cost has already reduced. But whether this particular solution is optimal or not, for that we have to check. We have to do the optimality test with this particular solution, and then only we can confirm that the solution is optimum or not. So I am doing the optimality test again. So to do the optimality test, as I have said, you have to check the number of solution has to be n plus n minus 1. So in this case that has to be 6. So 6 variables, 6 basic variables, and we have got 6 solutions, 1, 2, 3, 4 and 5, 6. And then we will calculate again for allocated cells. We will calculate UI and Vj. So we will calculate UI and Vj. So last time we have chosen this as 0 and that as 0. Now I'll choose this particular U2 as 0. So if U2 is 0, then we'll look at the allocated cells. So this is 19. So in that case, it will be 19 in this case, and this 0 and this 16 gives you 16. So when I've got 19, I've already used up this allocated cells. I haven't used this allocated cells, so this is 19. This is 18, gives you minus 1. So I've used up. So again, I'll check which allocated cell I haven't used. So I haven't used this. So minus 1 and this 19 gives you 20. And this 20 gives you 0. 0 and 18 gives you 18. So you have to practice this a little bit. Or again, I'll do, say if I'm taking this as 0, I'm taking this as 0, I'm repeating for your practice. So allocate cell, this 18, this 0 and this 18 gives you 18. This 0, this 9 gives you 19. 19 and 16 gives you minus 3, because this plus this is equals to this. Cij equals to Ui plus Vj. So this 18, this 19 gives you 1. This 20 gives you 19. So now, okay, this 19 and this 18 gives you minus 1. So I have already got all Ui and Vj. Now I have to calculate Wij for non-allocated cells, and Wij, depending upon the Wij, we will calculate we will decide whether the solution is optimum or not. So for Wij, the formula is Wij equals to Cij minus Ui plus Vj. So for this cell, this is already positive, so I am not writing the positive value. 20 minus 3 plus 19, so that gives you, this is also positive value. 1, this is also positive value. 25 minus 19 plus 1, so 25 minus 20 gives you plus 5, so it's a positive value. I'm not interested in the positive value, I'm interested only in the negative value. So this is 21, so this is also positive value. 21, 23, this is plus 5, so this is also positive value, and this is also positive value. So that means here all the Wij, all Wij are greater than or equals to 0. That means this solution is optimum. This solution is optimum. Hence, we will write the final solution as, so the transportation, so finally we write down the solution of the transportation problem as x13 equals to 35, x14 equals to 65, x21 equals to 60, x22 equals to 20, x32 equals to 50, and x33 equals to 40. And the total transportation cost, minimum transportation cost as equals to 4870. That is what we have obtained. So this completes the problem of transportation, and this is how we have to do the optimality test. So 3 steps to solve the transportation problem. There are 3 steps. First step is to check whether the problem is balanced or not. Second step, after it is balanced, then you have to go to the second step. If it is not balanced, you have to balance the problem and then go to the next step. In the second step, you find out the basic feasible solutions by either matrix linear method or north-west corner method or Vogel's approximation method. Please do not use north-west corner method. Use VAM or matrix linear method. So after you find out the initial basic feasible solution, then you go to the optimality test. Third step is to go to the optimality test. The optimality test can be done if the number of basic solution is m plus n minus 1. That means where n is the number of rows, n is the number of columns. Like in this case there are 3 rows and 4 columns. In this case there are 6 solutions, 6 basic solutions. If the number of solution is less than 6, then something needed to be done. That we will discuss in the next class. So in case of optimality test, you have to find out the for allocated cells you have to find out UI and VJs. So after you find out UI and VJ by taking one of them as 0, then you find out for non-allocated cells you calculate the Wij values. If the Wij are all of them are greater than 0, greater than equals to 0, then the solution is optimal. If they are not greater than equals to 0, then you have to start from the most negative cell and form a loop through the existing allocated cells and do the change of the allocations. And that's how. And with the new solution again you have to check the optimality test, and if the optimality condition satisfies, then the problem is completed. Thank you.